Okay, on day 3 of this unit, we got into the product rule and the quotient rule for finding derivatives. So first, starting with the product rule, this is kind of a visual representation for why the product rule makes sense. We have this rectangle that has a width, which is defined by the function f of x, and a height that is defined by the function g of x. So therefore, the area, which I called h of x, is equal to f of x times g of x, just length times width, right? Or length times height. So if we're thinking about the derivative, well, let's just say only the width is growing right now. So how that would look is we could extend our rectangle, right? So that the width is growing. And if the width were growing, then we would define the area by f prime x, the change in area by f prime x multiplied by the height g of x. Okay, but now let's say that not only is the width growing, but the height is also growing. So at the same time the width is growing, the height is growing at some rate too. Right? So they're going to grow and meet each other. Well, then we have to take that into account as well. So if the height were growing, we would take the width and we'd multiply it by the derivative of the height. So if they're both changing at the same time, we just add those together. We get f prime g plus fg prime, and that is exactly what the product rule says. So then let's say we want to apply this now. So let's look at an example. So we notice here f of x, this function is defined by these two functions that are getting multiplied together, x plus 1 cubed and x minus 5 squared. So what we're going to do is we're going to take the derivative of that first function first. So we get 3 times, here I'll do it in blue here, 3 times x plus 1 squared. And then we're multiplying that by x minus 5 squared. So this is f prime g, okay, plus, now we're just going to have f again, so we have x plus 1 cubed. And now we're going to multiply that by g prime, which is 2, so I'll put the 2 out front, times x minus 5 to the 1. So now if we want to describe the slope of this function, well, this function, the derivative, will tell us the slope at any given x value, and we found it using the product rule because these two functions are multiplied together. So moving on to the quotient rule, I don't really have a good visual to explain the quotient rule. We have a couple of rhymes we use, or just ways we can try to memorize this. But if we have a function that is two functions divided, f of x divided by g of x, the derivative is f prime g minus fg prime over g squared. So first of all, we can notice that this is like the product rule on top, except it's being subtracted instead of added. So if you're getting this mixed up, just always remember, take the derivative of the first function first, multiply it by the second function, then leave the first function alone and multiply that by the derivative of the second function. The rhyme we sometimes use is we say low, the denominator, low, g of x, multiplied by d high. So we say low d high, low multiplied by the derivative of the high, less, subtraction, high d low, then square the low and there you go. So we have low d high less high d low, then square the low, and there you go. I say derivative of the first one, leave the second one alone, minus, leave the first one alone, times the derivative of the second one, all divided by the denominator squared. You do what you need to do to get this memorized because it will show up pretty frequently. So let's look at an example. Okay, so we have f of x equals x minus 5 to the 4th divided by x plus 2 cubed. We want a function that will describe the slope of this function f at any given x value. So what we're going to do is we're going to do low d high. So we'll copy the low first. So the low is x plus 2 cubed. Let's copy that. Okay, multiplied by d high. So that's 4 times x minus 5 to the 4th. To the cubed. Third, sorry. The third. Okay. Less. Okay, just needed to move that for a second. I was running out of room. Okay, so then we're going to do high, so x minus 5 to the 4th. D low, so the derivative of low is 3 times x plus 2 squared. And then we're going to square that low. X plus 2 cubed squared is going to be x plus 2 to the 6th. So then there may be some simplification, but these are a lot of high multiplicity factors here, so it would be hard to multiply these out and simplify. This is our derivative. We have the, here, one sec, all right, I'm going to color code some stuff. So f prime x, that's right here. And then we multiply that by g of x, which is right here. Okay, and then we did f of x, which is right here. And we multiplied that by, I guess I'll have to do black here, by g prime x. Okay, so g prime x, we split up, we put the coefficient up front, but there's g prime x. And then we just squared g of x in the denominator. So that's our full example worked out. This just in, I can do different colors, and I just found that out. This is totally going to change my video game here. So here we go. There's the g of x squared. So there's a lot of pieces in quotient rule and a lot of opportunities for you to make mistakes. So you have to be very careful with these and really make sure that you understand or that you have it memorized what order everything goes in. So in the next video, I'm going to show how the quotient rule is used to show some derivatives of some of the trigonometric functions that we work with pretty frequently.